Jim.
Good morning, Mr. Commissioner. Brian Wallace, Commission Counsel. I am here to introduce the second panel on the predation hearings. These gentlemen will address the issues of principally of fish predation, but also there'll be some discussion of birds. Dr. Christensen has been here before yesterday and has been affirmed. And with him, or next to him, is Mr. Jeremy Hume and Mr. Gordon McFarlane. And I wonder, Mr. Giles, if you could affirm the new witnesses.
Yes, the two new witnesses, you solemnly affirm that the evidence given by each of the hearing shall be the truth, the whole truth, and nothing but the truth?
Yes, I do.
Yes. Would you state your name, please?
Jeremy Hume.
Would you change your name?
Gordon McFarlane.
Thank you. Counsel?
Thank you. Mr. McFarlane, let me start with you. I would ask, Mr. Lunn, if you could put tab 24 from the Commission's documents on the screen, which, sorry, that's the wrong one. Mr. McFarlane is tab 25. Just if I may briefly, Mr. McFarlane, the document on the screen, is that your curriculum vitae?
Yes, it is.
Mr. Giles, could we mark that, please, as the next exhibit?
Exhibit 800.
Mr. McFarlane, you are a DFO scientist emeritus
Yes.
at the Pacific Biological Station, and you graduated from the University of Winnipeg in science in 1971 and have been involved, I think, in fisheries research ever since.
Yes, that's correct.
And for the last 30 years, you have studied marine life extensively in the Georgia Strait, correct?
As well as other parts of our coast, yes.
Thank you. And that research centers on biological parameters, that is age, growth, and mortality, et cetera, to be used in stock assessments and examining climatic and oceanic factors influencing the dynamics of marine fish and the physical, biological, and fisheries oceanographic linkages of large marine ecosystems. Is that
Yes,
cover it?
Yep, that covers it.
In the course of this research, am I correct that you have done from a field research collecting and analyzing stomach content data on predator-prey relationships in British Columbia waters?
Yes.
And you have also studied the biology and distribution of sharks and skates off the west coast of Canada?
Yes, I have.
You were, I think, the head of marine fish population dynamics at PBS from 92 to 2000.
Yes.
And the head of the groundfish research section prior to that.
Correct.
You're a long-time member and advisor to the international negotiating teams for the INPFC, the Canada-U.S. Groundfish Committee, Pisces, the Pacific Hake Scientific Working Group.
Yes.
And you've participated in the development and conduct of a number of international research projects.
Correct.
I understand you've authored some more than 100 primary publications on biology and over 100 technical publications relating to stock assessment of Pacific marine fish.
Correct.
Thanks. Mr. Commissioner, I would submit that Mr. McFarlane is qualified by his experience as an expert to speak to marine fish predation on sockeye salmon. Thank you. Mr. Hume, I'll ask Mr. Lund to put your CV on the screen. Thank you, Mr. Commissioner.
That was marked as 800. That's 800.
Thanks. Thank you. Mr. Hume, can you identify this document on the screen as your curriculum vitae.
Yes, it is.
And Mr. Giles, could you mark that, please, as the next exhibit?
Exhibit 801.
Mr. Hume, you have a master's degree in aquatic ecology from UBC in 1979, correct?
That's correct.
And your career has focused principally on research into the ecology of juvenile salmonids, particularly sockeye salmon.
That's correct.
You first conducted research, I believe, for DFO on juvenile sockeye in Babine Lake. You were then with the BC Ministry of Environment, where you conducted research into management-related freshwater fishery problems, correct?
Yes.
And for the last 24 years, you have been the senior fisheries biologist for DFO's Lake Research Program, the principal objectives of which are to determine the trophic status, productive capacities, and limiting factors for sockeye salmon rearing in nursery lakes.
That's correct.
Great. Am I correct that during the course of this work you have also dealt in field research, collecting and analyzing data on the abundance, survival, and growth of juvenile sockeye in lakes? And in recent years, you have initiated and conducted and reported on the predator control program for northern pike minnow in Cultus Lake.
That's correct, yes.
You have authored some 10 primary and over 50 technical publications concerning the biology and ecology of juvenile salmonids in freshwater ecosystems.
Yes.
Mr. Commissioner, I submit Mr. Hume is qualified by his education and experience to speak to freshwater predation on sockeye salmon. Thank you. I wonder if I might start. Thank you.
Mr. Commissioner, I was wondering if we could change the exhibit number. We provided the Commission with a redacted version of the resumes that took out personal information. We have that in the list at this is the Commission's list of documents at tab 24, and they have a CAN number also. It was that the Commission provided a redacted version at tab 24.
The Commission.
The Commission list, yeah.
The one I have is not redacted, but may I suggest that we find the redacted version and replace it?
We have it right here. And I have the CAN number too, if Mr. Lund wants that. It's 185597.
That's the document that we filed. It is listed as tab 24 with that CAN number, so I imagine there's a redacted version elsewhere.
Oh. Okay, well, we have a redacted version. Okay, well, sorry about that. We'll have to deal with this later.
I suggest that we will replace this with a redacted version, taking out Mr. Hume's personal information today, as I hope. Thanks. Mr. Hume, the same issue arises with respect to Mr. McFarland's CV. Thank you. Mr. Hume, you've had an opportunity to review the Project 8 report that the Commission had from Dr. Christensen and Dr. Treitz.
Yes, I have.
Do you have any comments on the assessment in that report of the potential impacts of freshwater fish predators?
Yes, I do. I agree in general with their assessment that freshwater predators did not contribute to the decline in sockeye production in Fraser River. I base that on my own research, looking at fry abundance in the Quesnel, Shuswap, and Choco lakes, and finding no change in survival rates with time in those lakes, which indicates that mortality problems are not occurring in freshwater. So in general, I agree with their conclusions. I note that they have missed a few important documents in their research. The first one was in 1941 by Dr. Ricker on consumption of sockeye salmon by predaceous fish in Cultus Lake. The second one would be a paper by Ward and Larkin on cyclic dominance in Shuswap Lake, where they studied rainbow trout predation as well. And a third one is also in Shuswap Lake in 1989 by Gilhausen and Williams, where they studied a number of predators of sockeye salmon, including rainbow and cutthroat and burbot as well.
Thank you. You have also written on the issue of rainbow trout predation on sockeye, correct?
I have, yes.
And I wonder, Mr. Lunn, if we could have tab 30 from the Commission's documents. This is a document that you were a co-author on, I see, Mr. Hume, in 1989, which deals with rainbow trout predation on sockeye. What was your overall conclusion in that report?
For the larger rainbow size classes, kokanee and sockeye salmon are a major food source for these fish. In fact, the larger, what they call trophy rainbow trout, require the presence of either kokanee or sockeye in the lake with them in order to reach their large size. We were looking at this study from a rainbow trout point of view rather than from a sockeye point of view. So their actual impact on sockeye wasn't considered in the study, but they did provide, and particularly in dominant years, they provided a major source of food for the rainbow trout in the lake.
Thank you. And does this paper?
Yeah, sorry.
Does this paper reflect your current view on this relationship?
Yes, it does.
Thank you. I wonder, Mr. Giles, if we could mark the paper, 1989 paper referred to of Parkinson, Hume, and Dolligan as the next exhibit.
Exhibit 802.
Next paper I would like to direct your attention to Mr. Hume, actually, let me just introduce this by referring to your work in Cultus Lake. You've been actively involved there with respect to the pike minnow and the removal program over the years.
Yes, I have.
I have a couple of papers here that I'd just like to refer you to, and perhaps you can use those as a vehicle to tell us how information and knowledge on the pike minnow and the effectiveness of the program have developed over the years. And the first paper I would refer to is at tab 34 of the Commission's Book of Documents. And this is a 2005 paper by William Gazy, and you're familiar with that paper?
Yes, I am.
And
Sorry, it's not what's up in the... oh, yeah. Okay.
I think the copy we have is missing the cover page,
Right.
so you really have to go to the third page to see the author's name. Does that paper identifies compensatory predation as the causal mechanism for low freshwater productivity?
I believe that's on the next page.
Yes, that conclusion is on this page 3 under conclusions. Thank you. First of all, can you explain in lay language what that means and provide us your views as to whether that is an accurate assessment?
Compensatory mortality is, well, I always have a hard time explaining this one. basically, if you have a fixed number of predators, they're always hungry, and so they've tried to eat as much as they can. If there's not enough fish in the lake, the predation rate on those, if there's a small number of fish in the lake, the predation rate on those fish will be higher than if there's a larger abundance of fish.
Right.
So at very low densities, the mortality rate will be higher. Low prey densities, mortality rate will be higher on the fish than at high prey densities.
Thank you. And is that the issue in Cultus Lake?
Yes, it is.
Mr. Jones, could you mark that paper by Mr. Gazy, please, as the next exhibit?
Exhibit 803.
Now, if I may ask you, Mr. Lund, to put tab 32 on the screen, please. Mr. Hume, this is a paper that you co-authored, a CSAS paper, in 2010. And that's a more recent assessment of the status of Cultus Lake sockeye, correct?
Yes, it is.
And it discusses, I think, the efficacy of the recovery measures up to 2010 as well.
That's correct.
Now, did that assessment looked at the predator control measures?
Yes, it did.
Can you give us your views on the efficacy of the predator control? The predator at issue here is the northern pike minnow, correct?
Yes, we removed only northern pike minnow from the lake.
Okay. Can you just describe that program and the limits or not on its effectiveness?
In 2004, we did a mark recapture population estimate of the pike minnow in the lake and came up with approximately 60 to 70,000 adult northern pike minnow in the lake. And from starting in 2005 through to, currently right now it's still ongoing, we removed approximately 45,000 adult pike minnow from the lake. There's been there's been replacement from the younger year classes into the adult life history stage, but we removed a significant proportion of the northern pike minnow from the lake. This has resulted in increased survival. At the current densities of sockeye in the lake, has resulted in increased survival for those fish relative to years when no pike minnow removal occurred.
Are there points, is there a lesson to be learned about the effectiveness of predator removal programs from the Cultus Lake circumstance?
It's hard to expand this study to other lakes in the system. Every system will be different. Cultus Lake is a fairly small sockeye rearing lake with a relatively easy population of predators that we could remove. We can capture and remove. Certainly, I guess so in Cultus, it's shown to be an effective method to work at low sockeye densities. Actually, if we go to figure 11, I believe it is in this paper. I'm not sure what page number that is, I'm sorry. Towards the end. Figures are all at the end.
Page 41.
So this figure shows survival. Survival on the vertical axis plotted against the number of effective total number of spawners in the lake. The diamonds are there's no pike minnow removal, and the circles are years when we did have pike minnow removal. You can see at higher densities that there's no apparent effect on survival at the high densities, whereas at the low densities we appear to have a much higher survival rate for fish, say less than 6,000 spawners in the lake. And so I guess what I think we can learn from this is that for populations that are in trouble, low densities of spawners, this may be in a way to help rebuild the population by increasing their survival. The lake's very small. It's unlikely. It's unknown whether this could be this technique could be transferred to other larger systems.
Yeah. To give a sense of the turning point in this model seems to be around 6,000 spawners, and this is in a lake that would support how large a spawning population?
We estimate that it could support anywhere in the 70 to 80,000, 60 to 80,000 range.
Has there been any study on the impact on other ecosystem impacts from the predator removal program in Killis Lake?
There is some work being done, yes. Our regular midwater trawl work that we do on the lake monitors all pelagic fish in the region. As well, we do an annual spawning beach seine survey around the lake, usually in September, looking for it would detect gross changes in population estimates, in populations of other fish.
Are you able to draw any conclusions about the impact of the program on other parts of
the data hasn't been completely analyzed, but certainly there's been nothing that's looked surprising in quick examination of the data sets.
You say nothing that looks surprising.
Sorry, there's no obvious increase in abundance of any species that we we're seeing the same sorts of abundance of species that we've always seen in previous years.
Thank you. Thank you, Mr. Hume. Mr. McFarland, let me ask you the same question. Do you have any comments on the assessment of the Project 8 report on potential impacts on Fraser River sockeye of marine fish predators?
I've read the report, and I don't have any differences of opinion on their final conclusions, which is that marine fish probably was not a major factor in the 2009 reduced returns. I also agree that much of this is based on limited data on many of these species, and that in general it'd be nice to be able to look at a little more closely at some of the species as they suggest.
Okay. So you would agree with the recommendations as well?
I agree with the recommendations in general, although I would change one or two of them up a little bit in terms of species groups to be looked at, in terms of the development of a predator or a prey diet database.
Can you be more specific?
Yes, on which one?
What changes would you make on the species?
On this, there's a number of things. If you want to stick to the Strait of Georgia versus the open ocean, there's different species groups you would want to concentrate some of your efforts on. If you were looking at the Strait of Georgia only, I would concentrate on a number of species, and I haven't got in front of me, sorry, which ones I'm thinking of, but
perhaps have a look at page 82 of the Project 8 report. I'm sorry, I've forgotten the exhibit number.
Could you say the name of the document again, Andy?
Oh, it's the Project 8 report.
Oh, 780.
780, thank you.
okay, they've basically come up with 6 species that they would recommend are potential predators of interest that more information is probably needed on. And most of those species are outside of the Strait of Georgia. I don't disagree that it would be nice to have more information on those species, but there are a number of other species outside of the Strait of Georgia that they also have talked about in their report where more diet data would be needed. I'm thinking specifically of things like northern stocks of arrowtooth flounder and some of the other groundfish species. In the Strait of Georgia, I think it's important to concentrate your studies not only on the 2 species mentioned here, which are river lamprey and the common murre. I would suggest that there should be a lot more work on some of the other species, such as dogfish sharks. Now that's as a potential predator, but there are other species in the ecosystem context that should be looked at as well, which are not predators but may be competitors.
Thank you. Just on an aside from Mr. Giles, did I mark the 2010 CSAS report on the status of Cultus sockeye as an exhibit?
You did not. That'll be Exhibit 804.
Thank you. Thank you, Mr. McFarland. You have some expertise in salmon, shark, I think, among other sharks. I wonder if I could have tab 26 put on the screen, please. This is a 2010 report done by Williams and others. You're familiar with this report, Mr. McFarland?
Yes.
And do you agree with the conclusions of the authors on the salmon shark?
Well, their conclusions, there's a number of conclusions. One is that they wanted to attempt to come up with some sort of reasonable biomass estimate. Another is that they don't actually conclude much in the way of the importance of salmon shark. They present a lot of their interpretations of what might be important. For example, predation on Fraser River sockeye, predation on other species which apparently are in the hot zone that they speak of, those types of things. So, do I agree that what they've done is reasonable, and are the conclusions reached reasonable based on their analysis? In general, I think I was confused as to why they limited their data in certain ways. I'm not sure I agree with the idea of using these types of techniques for sharks. It's line transect theory and whatnot, and models are difficult at the best of times, let alone for sharks. However, given that these people are good at this type of work for marine mammals, I think it's if we accept that their conclusion is that in the hot spot that they speak of, which is the southern tip of Queen Charlotte Sound, or Queen Charlotte Islands in Queen Charlotte Sound, that there may be in the neighborhood of 10,000 sharks, of which possibly 4,500 sharks are salmon sharks. Okay, I accept that's an estimate that comes out of their analysis. That you then have to say to yourself, okay, does 4,500 sharks over the course of July and August in certain years, because in some years they found no sharks, does it mean anything in terms of impacts on the actual dynamics of the stock? Obviously it means something to the individual fish that got eaten, but it doesn't mean anything to the dynamics. And there's not a lot of information. In Project 8, it recognizes the lack of diet information on salmon shark, but they're episodic feeders. They're also opportunistic feeders. They feed on a lot of things other than salmon. That particular area is fairly rich in other species of forage fish, particularly in the last number of years, sardine. One of the reasons the whales seem to congregate off that area is the presence of sardine. So all those things together indicate to me that yes, there's salmon shark there. In my own studies of looking at bycatch in other fisheries, that also shows up as an area of salmon shark abundance, as does other areas on our coast. It's not the only one. And so the question really comes down to, is there evidence that they are feeding on salmon in that area? There is no evidence, and doesn't mean they aren't. It means there's actually no data from that area. However, in areas where there is data, salmon shark definitely feed on salmon, hence their name, but there has been no linkage between salmon shark predation and declines or increases, for that matter, in salmon populations. And I'm speaking specifically of Prince William Sound, where most of the work on salmon shark has been done.
Thank you. Mr. Johns, could document shark aggregations in coastal waters, British Columbia, Williams et al., 2010, demarked. This is the next exhibit, please.
Exhibit 805.
Dr. Christensen, it's been suggested, and I take you to Canada's tab 13. These are two papers that relate to the rhinoceros auklet, a bird found on Triangle Island off the northwest coast of Vancouver Island, I think. And it's these two papers, you're familiar with those?
Yes, I am.
And I think they both come to a conclusion that the rhinoceros auklet is a bird that we ought to be paying attention to in the context of predation on early sockeye migrants into the ocean. Correct? That's their conclusion.
Yes.
Yet the rhinoceros auklet didn't make the cut in your analysis. I'm wondering if you've considered these remarks and what your views are.
We did look at information about the species when we wrote the report. We had a lot of species to cover. We did not find it likely that this would be an important species based on that information. And in examining what we could find of information about trends in the species, abundance and trends, the conclusion was it was a fairly rare species, and that there was no indication that its abundance had been increasing in recent decades. So that was they were the reasons why we did not include it. In examining it again now, I find it very unlikely that it would have any significant impact on the Fraser River sockeye salmon, given the very limited time that there's an overlap in spatial distribution, given the numbers. Compared, for instance, to salmon shark we just heard about, rough indications would be that salmon sharks could probably eat 2 orders of magnitude more than the rhinoceros auklets. So overall, I do not think that this is a species that may have contributed significantly to the predation mortality of Fraser River sockeye salmon.
Thank you. Mr. Giles, may I ask you please to mark first the environmental control of the breeding success of rhinoceros auklets at Triangle Island as the next exhibit.
Exhibit 806.
And the document that's at tab 14 of the Canada's book, Forage Fish of the Pacific Rim as revealed by diet of a piscivorous seabird, synchrony and relationships with sea surface temperatures as the next exhibit.
807.
And Dr. Christensen, I believe you have summarized what you've just told us in a short document that you provided to us and we've circulated. Could that be put on the screen, please, Mr. Lund? Dr. Christensen's response, which is in written form, pretty much what you just gave in evidence?
That's correct, yes, though this one does not talk about how much they would have consumed.
Thank you. I ask Mr. Giles if this could be marked as the next exhibit.
808.
Finally, Dr. Christensen, this morning there was a discussion about DFO's ecosystem research initiative arose, and this is a topic that you and Dr. Traitz address at page 78 of the Project 8 report. If that could be put on the screen, please, Mr. Lund. The comment, I think the tenor of your comments in the report itself are that the level of support for this initiative is insufficient to ever meet the goals of integrated management. Could you care to expand on that and any other comments from what you heard on the discussion of the ecosystem research initiatives at DFO?
It is clear that the scientists at DFO are doing an incredibly good job at moving out the research ahead, and that they are doing this with very limited resources. If I look at the Ecosystem Research Initiative and the documents that describes this, I find a lot of good intention in it. I do, however, not see a clear strategy in the way it has been implemented. The funding envelope of, I think, around 500,000, well, that's 2.3 million for 5 areas, which on average would be 400,000 to 500,000, is a very limited amount of funding for a research initiative that is fundamental for where DFO is moving with its integrated management. The way that this funding has been broken up into piecemeal projects, to me, indicates a lack of strategy. It's small projects, and I have problems seeing how this initiative is going to prepare DFO and the overall community here on the West Coast when it comes to predicting how the Strait of Georgia will look in 2030, which is a key objective of this research. So I really feel that this funding has been used to do more of the good work we are already doing. That was in quotation mark, because we is not me. But the good work that the DFO scientist is already doing, it's been allocated for that use, as far as I can see from the documents. And it has not been used strategically to promote the chief objective.
Commissioner, I have no further questions for this panel, and Mr. Timberg is next in line.
For the record, Tim Timberg for the Government of Canada, and with me my colleague Geneva Grande McNeil. We've heard this morning about conversation about the importance of data and the importance of ecosystem modeling. And I'd like to start with you, Mr. Hume, as to, can you explain for the Commissioner the work that, whether your work includes collection of freshwater data?
Yes, it does.
And can you describe what that means? What do you do to collect that?
Our Lakes Research Program studies juvenile sockeye fry in lakes, mainly, obviously in lakes. We collect physical, chemical, and biological, limnological data from the various trophic levels that supply food to the sockeye salmon, as well as occasionally look at the predators of salmon as well, but also their competitors too. Data is collected through the fish part of the data is collected through hydroacoustic population estimates, and with actual physical sampling through through midwater trawling.
Okay. And can you describe generally the areas where that data is collected?
We've sampled just about every sockeye rearing lake in the Fraser River system, except for a few of the very small ones, or low lakes with very low populations, any of sockeye. And we have detailed data over a long time series going back to 1975 for Quesnel, Shuswap Lake, Cultus Lake, and off and on for Choco Lake as well. And a few other lakes as well. We have time series, but not as long as those.
Mr. McFarland, can you explain whether you in your work collect marine data, and if so, what kind of data do you collect?
Yes, I do, and I collect. Generally, cruises go out to answer a question or a specific set of questions, and it could be things like examining the abundance and distribution of specific species or a specific group of species. As part of that, we would also collect other types of information, age, sex, length, all of the biological parameters that would allow us to say something about the stock structure. We, in many cases, in my own surveys, I generally try to take diet information from the key species as well as the incidental species I'm taking. Some other groups do the same. Some do all the first parts, but not the diet part. It is time consuming. We also take physical oceanographic and biological oceanographic, so lower trophic level, abundance of copepods, euphausids, that type of thing, along with all the other information. So at sea, those are basically the types of information that we would use, and we use equipment such as trawl nets, traps, and long lines, as well as in some cases we might put out specialized gear for a specific purpose, such as modified gill nets in some cases, very seldom. All of our diet work comes from trawl nets because, of course, they're passive in terms of they're not drawing the fish to a bait of any kind.
Right. And Dr. Christensen, do you collect any data in your work in the freshwater or marine waters?
Not in my current work, no.
Okay. And I'm just wondering if, Mr. McFarland, if you could comment on the relationship between data and ecosystem modeling. And we've heard that ecosystem modeling earlier is not very expensive, but I'm wondering about the cost to collect this data and the relationship between data and ecosystem modeling.
Yes, the depends on the ecosystem model, I suppose, but if we're talking about the type of modeling that's suggested in the report, which is EcoPath with Ecosim, it is very data hungry in terms of diets, consumptions, abundance estimates for numerous species, and that type of information, so collected at sea and transferred into databases which can then be used. Building the model, I mean, Vili's the guru of building these types of models, and I'm sure he's correct in saying that he can build them pretty quickly. The ones I've worked on are very nice to work with, but the collection of the data is incredibly expensive in terms of dollars and in terms of ship time.
Would it be fair to say that you need both then? You need the data to feed the model?
Well, it would be fair to say to me, absolutely.
Okay.
Otherwise, you have to make the data up.
And does anybody else on the panel have a comment with respect to that relationship?
This is what Senator McFarlane said is totally correct. One question, though, is what data do we need? As it was pointed out this morning, scientists always want more data. We cannot collect all the data, and it's very important that we use models to guide us with regards to what kind of data do we need to collect. So the starting point is what policy questions are important. We use the models to guide us then, and to guide, not the least, the very expensive data collection. That can be much more efficient if it is driven by model studies.
Okay, thank you. Mr. Hume, if we could, Mr. Registrar, actually, if we could turn to Canada's List of Document, tab 1. And if we could turn to page, it's 1330 in the top right-hand corner. And we'll be looking at the text on the right-hand side of the page. Mr. Hume, before I get to a specific question with this document, would you agree that over the lifetime of a sockeye population, like the entire over the entire lifetime of a sockeye population, most mortality occurs in fresh water?
Yes, I would.
And using this document, could you explain to us the freshwater mortality and in stages? I'm going to sort of break down the stages from egg to fry. What is the freshwater mortality between going from egg to fry?
Around 8% overall for all salmonids. Sockeye probably a little bit higher than that, around maybe 10%, 10 to 15%. Sorry,
right.
Survival, that is, not mortality.
Okay, and we're looking here at, and so first of all, can you identify this document that we have in front of us?
Yes, I can.
And what is it?
It's a comparative study review, well, there's a comparative review of Pacific salmon survival rates by Dr. Bradford.
And he's a colleague of yours?
Yes, he is.
If we could have this marked as the next exhibit. Going back to page 1330, then what you've just said about the rate of mortality, the 8%, then you're getting that in the end of the first column on the right-hand side there?
Yeah, that's 8% survival, it's 92% mortality.
Okay, that's helpful. And then, can you explain the freshwater mortality from the smolt stage to entering the marine waters? Oh, we've done egg to fry. Sorry,
we don't actually know what.
Sorry, I'm going to backtrack. I've missed a step here. We've done egg to fry, and I'd like to now ask you from fry to smolt. And I understand that's at the bottom of the next paragraph.
Actually, the next numbers that he provides there are total mortality from eggs to smolt.
Yeah.
So that includes the egg to fry mortality as well, but it's 2% survival or 98% mortality on average occurs.
And that's for the sockeye salmon?
That's for sockeye salmon, yes.
All right. And then my third question then is, what can you tell us about freshwater mortality from smolt to the marine waters?
We can't say a lot about that at the moment, actually, because until very recently there's been virtually no work done on mortality in the smolt migratory corridor. There's been one study done by Dr. Welsh using acoustic tags in the POST system, which I believe the mortality from and that was just large atypical smolts released from Cultus Lake. They were very large, about double the size, and well, more than double the size of normal smolts, and they had a high mortality. I believe around 40% mortality before they reached when time they left Cultus Lake and to the past receivers at the mouth of the Fraser River.
All right. And so what would you say then is the overall freshwater survival?
Very low, again, is somewhere in the range of 2%.
What would be the percentage of survival in a year for a good return?
Freshwater?
Yeah. I'm trying to ask for a range. So if the average is 2%, I'm wondering if you give us a range, like a bad year and a good year.
Bad years would be certainly be observed in some years to be less than 1%, and up to maybe 7% survival.
And 7% for a good year.
For a good year, yeah.
All right. And can you explain the role that predation plays in this low freshwater survival rate?
The causes of mortality in the freshwaters is quite varied and not very well understood, to be quite honest. Presumably, from the egg deposition to emergent fry, mortality certainly plays a role. Sculpins and other small fish and invertebrates such as dragonfly nymphs and things like that are large causes of mortality, but also in that stage, just simple physical forces, excessive stream flows, cause physical disruption of the eggs, just being dislodged from the gravel and being floating downstream causes problems. Other factors would be disease and parasites at various stages. The fry are very vulnerable to predation, presumably when they first leave the gravel and migrating down the stream, and then they typically spend quite a bit of time along the shorelines before they get out into deeper water.
Okay.
And they'd be quite vulnerable there as well.
So what information would be helpful to better understand then Fraser River sockeye in the freshwater environment?
A continuation of what we're doing, looking at longer-term data sets and other lake systems would be very useful. But I think our biggest area of lack of knowledge is what's happening in the smolt migratory corridor. We don't really know. We don't know what the mortality. We don't even know what the mortality rate is, or what causes mortality, or whether there's points where mortality is higher than at other points along the system. So that would probably be my major recommendation. Would be look at both the smolts and also look at the condition of the smolts as they leave the lakes.
Okay,
for energy content. See how their ability to withstand the rigors coming up.
And okay, and can you describe how your work, whether your work takes into account ecosystems?
Yes, it does. We certainly study both the physical and chemical environment that the fish live in. We do primary and secondary trophic level studies as well. We've developed models looking at primary production and as a predictor of carrying capacity for sockeye rearing lakes. We've also looked at not to the same extent, but we've also done studies on top-down control of sockeye salmon through the predator work that we've done in both Cultus and Quesnel Lake.
Is your work incorporated into forecasting models at DFO?
Yes, it is.
Okay. And I think you answered this question this morning, but just for clarification, I think you said that there's no evidence that mortality of Fraser River sockeye in freshwater is increasing. Is that what you said?
That's Yeah, that's correct. Well, the lakes that we studied, so we have fry data collected in the fall of the year for a number of years for Quesnel and Shuswap lakes, and as well as the long-term, that goes back to 1975. And we also have long-term smolt data from Choco Lake, which goes back to 1948. And in all three of those cases, there's no indication that there's been any downward trend or upward trend, for that matter, in survival over that time period.
And what's the importance of the long-term data series? Why is it important to have long-term data?
So we can answer the questions just like you asked me.
Right. All right. Thank you. Mr. McFarlane.
Mr. Timbers, I wonder if I could just,
Certainly.
just for my understanding, if I could just go back a step, Mr. Hume, through Mr. Hume. You've asked him about the predation, about survival rates. And he's talking about some of the elements that bear upon this, and he mentioned cultus, for example, but just so I understand, are we talking about where the spawning is in the river, or are we talking about where the spawning is in the lake? Are there differences between those two aspects of spawning history?
Mm-hmm.
But more importantly, I'm not quite sure I fully understand what are the elements, how he's tying this together with, for example, he talked about the data that he's collected with regard to the rearing capacity of these lakes. How is this all tied together in terms of answering your question about survival rates? For example, he mentioned disease, but he's mentioned parasites. He's mentioned some of the elements that make the fry vulnerable to predation. I'm just trying to understand where food comes into this in terms of what's available for these fry in the lake system and how that bears upon their survival. So I'm just not sure I'm getting the picture here of all of the elements that bear upon the survival of the fry. I certainly understand some of the elements he's talked about, but how do I tie together all of these elements? So where the fish spawn, to me, is something that would be helpful to understand where he's making these, and the relationship of the capacity of the lake to survival, and the relationship of these other elements to survival, be it parasites, disease, whatever. Are there different studies going on here, or are you talking about one study, or is this different data that he's collected, or is it a single set of data? I'm just not clear on this.
I'll do my best, Mr. Commissioner, to walk you through that. I've been given 60 minutes to do so much, and it's difficult, so we're rushing.
I'm just getting a bit lost here.
No, fair enough. I'm just noting the pressures we're all under to try to explain a lot in a short period of time. Mr. Hume, what I'll ask you to do is to walk us through and you tell me if this is the appropriate approach to help unpack this. My thought is that you should first talk about the egg to fry stage in the river and the different impacts that happen with respect to freshwater survival in the river in the egg to fry stage. Then perhaps you could talk about the fry to smolt stage with the lakes and survival in freshwater lakes. And I think then the third stage is the smolt to ocean part, which you've said we don't really know very much about yet. So my thought is if you could unpack the first two stages, perhaps sort of the first year within the river, the egg to fry, and then move on to the year in the lake.
Perhaps I should first just say a little bit about what we do rather than what we don't do.
Sure.
Our work doesn't look that much at the causes of mortality for sockeye. We're looking mostly at the results of what the various mortality factors that are being happening to the fry population, sockeye populations.
And when you say the results, why is that?
We do that by determining abundance. We know the number of spawners, and we know the number, and we determine abundance of various life history stages. Sometimes we do summer surveys and as well as fall surveys, so we can break that life history. This is the mortality down to various life history stages. We do very little in work on actual factors that are causing the mortality to these fish at the time. Certainly, there's a difference in survival rates between, well, actually,
So perhaps I'll just ask you if you could focus then on the work that's being done and the information you have on the first stage between the egg and the fry stage in the rivers.
My group, our larger freshwater research group, has done some work on egg to emergent fries, which we call the fish as they leave the gravel and migrate down to the lake. But I haven't personally been involved with that.
And okay, and are you able to comment on any of the factors that that are at play that result in such a low survival rate at that stage?
Well, from our Cultus Lake experiment project, we've certainly seen the fry to smolt survive work that's not published yet, but we're just developing the data now. Is that by removing the pike minnow from the lake, or reducing the numbers of pike minnow in the lake, we've increased the overwinter survival of these fish by almost double. So on average, we were getting about 22% survival from fall fry to smolts going out of the lake in the following spring. And now it's it's more than double. It's around 50%, 55% survival on average.
All right.
So indicating that the predation is certainly a major factor in mortality during that at least that time period of their life history.
And are there other factors that you're aware of with respect to that life stage between egg and fry? And if not, is there someone that could inform us on that stage?
This is an area of research that we haven't really looked into all that much, to be quite honest.
Okay. Can you then, moving then from the fry to smolt stage, can you describe for the assistance of the Commissioner the work that you're doing with respect to the lake survival and your understanding of how the lake operates with respect to salmon productivity?
Certainly. Survival in lakes tends to be density dependent. Well, what we do know is that survival is density dependent in the lakes in most cases. The causes of the mortality we can't really put a handle on, because we haven't put a handle on. We know that predation must play a fairly large role, given the fact that our Cultus experiment, but also sockeye fry are found in a number of found in large amounts in certain fish species, such as the trout, cutthroat and rainbow trout. Burbot are also found to contain large numbers of sockeye fry. Pike minnow population fry predation rates are lower, but pike minnow tend to be very abundant, so they make up for low predation rates by large abundance.
Okay, and I'm just wondering if we could turn to tab 45 of Canada's list of documents. And I understand this document is some of the results of DFO's Lake Research Program. Perhaps you could use this to explain explain these results for us.
Well, this is the results of our fall fry acoustic estimates of the abundance of sockeye fry in Quesnel Lake. Yes, Quesnel Lake. It's plotted against effective female spawners on the bottom axis.
So that's the amount of female spawners, and on the left is the fall fry. And what does this tell us?
What it tells us is that at a certain density of effective female spawners, or abundance of effective female spawners, the mortality rate increases to keep the fall fry abundance basically at a constant level. We fitted a Ricker curve to this data set, and you can see at the far end that it's decreasing. The curve is the solid line is dropping down, but in actual fact, the measured abundance estimates that we received, abundance of fall fry that we've measured at those really high densities has not decreased along with as the model would predict, indicating that perhaps another model that doesn't decline at high densities would be more appropriate.
All right, and Mr. Commissioner, perhaps it's time for the lunchtime break, and I'll work with the witness to help fully explain this issue for you.
Can you just scroll down just a little bit?
Hearing is now adjourned until 2 p.m.